Okay, we'll get cranking here again so we can say on schedule. Got a little computer thing we're trying to take care of. So anyhow, next speaker, Mike McNeill. Most of you know him. And anyhow, Mike has a wealth of experience behind him. Until just recently, he was farming also up in the Algona area, but he's got quite a history. I guess we've known, and I've worked with him for at least 35 years. Don't know when I didn't know him. But where did Mike disappear to? There he is. He's going to jump on stage. So he asked what he should talk about, and I just said, well, you got a wealth of experience. You know how to handle crises. So as far as farming this next year, coping with drought, whatever, Mike, I'll turn the floor over to you for 5 minutes. Okay. Like this?
Yes.
Okay, we can do that.
Is this working?
No.
No.
And we're working with a sound system we're learning on, and during a program is not the time to learn, I guess. So you might have to hold this.
Can you hear that? Yes. All right. Sounds good. Well, you heard this morning a little bit about resilience in our human bodies. When we look at our farming systems, we need the same kind of resilience in that. And we have lost it. We are doing many things that have taken that resilience away. The same as what's happened in our human bodies. So we have sick soils, sick plants, sick animals, and we're sick. Our nation is sick. So I want to talk a little bit about putting some resilience back into your farming systems. Heavy emphasis on the word system here. So we're going to be talking about farming systems and what we can do. Now, what do we got for resilient? What do I mean? Well, I mean, I want you to have a farming system that can withstand about any adversity that we could throw at it, particularly those that we have no idea that it's coming at us. Those are the tough ones. I put down some easy ones here, severe weather events. It looks like we are changing our climate a little bit. I don't know if I'd like to use the word climate change because I'm seeing weather that I used to remember as a kid. That's been a few years ago. We had some pretty severe weather then. We had some pretty nasty droughts. We had some pretty nasty windstorms. They do occur. Temperature changes. I can remember, being out there and loading hay. Back when we used a hay loader, that was before bales, and it was really hot, like 104 for northern Iowa. That's pretty warm. We haven't seen that for quite a few years. So those are all things we understand. And as I talk to growers, they, yeah, well, I have federal crop insurance, and I'm good. I'm all right. Whoa. Wait a minute, what if the whole country has a drought? How far away are we from running out of food in our country? Well, I was talking to some people that were having trouble getting food into northern part of New York because of that snowstorm. They didn't have diesel fuel. Well, that's not a big deal. We got plenty of diesel fuel yet, but it wasn't there. So the truckers didn't want to haul food up into that part of the area because they couldn't get enough fuel to come back. So they just didn't go. How long would it take grocery store shelves to go empty if they weren't resupplied routinely? 3 days. That is way too fragile. All right, I use that as an analogy. Our farming systems are that fragile. We have a really severe drought, and it's widespread. We have ourselves in serious trouble. So I've looked at its ways that we can prevent that. What if we have severe economic change? You know, we're seeing some kind of nasty inflation, and the price of nitrogen is like ridiculous. The price of new combines is more ridiculous. But that's just me. I'm used to buying a combine for $10,000. Now $1 million will hardly touch it. It's crazy. But it can get a whole lot worse. There can be political and social change. And I see that coming. I see it coming at us. It's kind of scary. What is your farm resilient enough that you can survive that? So we're going to explore that a little bit. What are the attributes of a resilient farming system? Well, knowledge is probably the first thing. Now, I'm preaching to the choir here because all of you are here for what reason? To gain more knowledge. So I don't have to really emphasize that too much to you because you've already figured it out. But if you look around the room, there's quite a few farmers that aren't here today. And they do not have that knowledge, nor do they have the desire to get that knowledge. So that's going to impact their farming system. The next thing that's probably most important is a healthy soil. Without healthy soils, you're not going to have a very resilient farming opportunity. Diversity. Diversity is really important. We've heard a lot about monocultures, and I have several growers that grow only corn. That's a monoculture as you can get. And I talked to them about diversity, and they're like, no, I know how to grow corn. That's all I'm going to do. I said, well, how about putting some livestock into your operation? Are you kidding me? No way. I said, well, maybe it isn't that hard. Have you ever thought about using animal manure instead of commercial fertilizer? Oh, yeah, I do that. I buy chicken manure. And okay, so now you've just introduced livestock into your farming operation. You got to think a little bit. Remember this knowledge thing? It also requires some thought. But you can bring diversity into your farm in many different ways. So think about how you're doing that. And then I threw out the last one there, limited reliance on outside funding. Remember, look at my hair color and you'll realize that I am a survivor of the mid-'80s farm crisis. Will that ever happen again? You bet it will. It will happen in a different way, but it will happen, and we will have some economic pressure. And if anything I learned out of all of that was to limit my reliance on outside funding sources. I can use some borrowed money for financing something, but boy, it's a very calculated thing. And I think very seriously about what could go wrong so that I couldn't pay that money back. And I know my parents went through a depression. That was their generation, very severe. Went through the mid-'80s farm crisis. And I saw that those who were relying on outside funding were in serious trouble. And it was serious, guys. I know a lot of you white-haired folks out here like me kind of remember that. But boy, I remember having, first time in my life I ever had a 357 pointed at me. I saw people angry enough to kill someone else, despondent enough to kill themselves. And then I saw people who, yeah, well, it's tough times, but we're getting along okay. Why? They had a resilient farming system. So let's explore that a little bit. I'm going to start with soil. We've already kind of covered the knowledge thing, because that's why you're here. So let's look at the soil. What do we need? Well, we need to increase the organic matter in the soil. That's a good thing, you know. I mean, we hear a lot about that. We need to increase the water-soluble organic carbon in the soil. That's what we really need to do. We need to enhance soil life. We hear a lot of talk, and the real buzzword today is cover crops. What are you really doing with cover crops? You're enhancing soil life. You have to feed the critters that are in the soil. And people, well, you know, okay, I put on quite a bit of fertilizer, so I'm okay. You know what? They need energy, just like you do. How do they get the energy? Well, they have to get it from somebody else. They get it from the plants. And so we need plants growing on there as much as we can year round. And I see individuals in this room that live up here at the Canadian border, and they say, well, you know, it's a little hard to grow plants up there in certain months. True. But as long as you can keep a plant alive on that soil, you're feeding the microbial life in the soil. That will then improve soil structure. There's other things that we can do to improve soil structure. Maintaining better worm population. How do you do that? Well, maybe a little less tillage. And maybe using a little bit of different chemistry when you're applying nutrients or restoring nutrients in your soil. All that then leads to improved water infiltration rates. Why is that important? Man, we got a serious problem. We heard yesterday about dead zones and stuff in our lakes and rivers and in our oceans. Why is it dead? Well, we're shipping all our nutrients downstream. And we're running out of water. Now, some people experienced a pretty good drought here in Iowa this year. And yet their next door neighbor didn't. Why was that? They had better water infiltration rates, so what rain we got went in the soil. I heard a quote earlier this week. Guy was talking, well, how much rain did you get? All of it. That's the key. If you can say all of it, you have a more resilient farming system. Balance the soil's minerals in your soil, and it needs to be balanced appropriate to the crop that you're growing. Let's explore that a little bit. Balancing the soil for the crop species and the biological communities that you're growing. You have to not only balance it for that crop, but for that rhizosphere around the root and the microbes that are interacting with your crop. How do we do that? Manipulate soil pH, improves the availability of nutrient plant uptakes. And you also need to accomplish the proper ratios of calcium, magnesium, potassium. So let's explore that a little bit. You've probably all seen this kind of a chart. You see that little green box in the middle. That's around a 6, well, what are we, about a 6.5 to 7.3 or 4 pH. If you have your soil at that pH, you pretty well have the majority of the minerals that you need being as available as they can be. But I kind of looked down the line here and I'm like, whoa, boron, that's way up, copper. All of these a much more acid soil. Okay, so if you've got it in this green box, what are you doing about those microbes? How are you assuring that your plants are getting the microbes that they need? That's when you maybe need to start, well, do I band some fertilizer pretty close to that plant root? Do I foliar feed it? There's more than one way to do it. But you need to think about doing it. Because if you don't, you got a little problem there. Look at molybdenum. We talked about that a little bit earlier yesterday, but molybdenum, way off the chart on the high pH side. So people with high pH soils that are struggling with that, probably molybdenum is not one of their biggest concerns. But many of us who are working with pHs that are less than 6.5, maybe down even into 5s, we have a serious molybdenum problem. And then we have a serious nitrogen usage problem. So, kind of remember this chart. It's one of the most important ones you could have. Maybe you ought to make a copy of it and stick it in your billfold, pull it out and look at it once in a while. Make you more money. Okay, I talked about balancing calcium, magnesium, potassium. We got 3 soils here. Soil A, soil B, soil C. pH is 6.8. So those of you who run soil tests and you run pH, P, and K, and maybe organic matter, that's your soil test. And your soil test says pH is 6.8. Yeah, I got mine pretty good. I'm right on money with it. Let's look at that a little bit. Soil A, 68% of the cation exchange capacity is calcium. That's good. Magnesium, 12. That's pretty good. 12 to 15, that's a nice area to be. Potassium, 5. Oh, that's real good. You're in good shape there. Sodium, 1.5. A little high, but not bad. Okay. Trace elements, all of the rest, 1.5. That's probably okay. You don't know what they are, but probably okay. Let's look at soil B. Same pH, 38% calcium. Whoa. We are way short on calcium. 42% mag. Now, I know that there's some people here in the room that have some farms like that. I know because I personally worked with them. Potassium, 5%. Everything else looked fine, but that calcium-mag ratio is way out of whack. Well, how do you fix that? You say, well, I'll put some lime on it. That calcium carbonate, that has calcium in it. That'll fix it. What else will it do? Raise the pH. You want the pH higher than that? No, it was just perfect. So what source of calcium can you use? Gypsum, calcium sulfate. That'll work. That does some kind of interesting things. It'll soften up the soil and give you a nice supply of sulfur, kind of for free. Buy the calcium, get the sulfur for free. It works. So that soil B can be fixed. Let's look at soil C. Now, same thing. It's short on calcium, but mag is not too high, 22%. A little high, but not bad. Where's the problem? Sodium, 21%. That soil's dead. You have trouble growing weeds there. That's a real problem. Harder to fix, but it can be fixed. You can balance those. Here's a picture I think that really shows that. See that cloddy soil there? High mag soil. Many of you have seen that kind of thing. Then right next to it, you see that line going through the field? It's a lot more mellow on the other side. How did that happen? Well, that's what gypsum can do for you. You can soften that up. And once that soil's softer like that, what happens to your water infiltration rate? Goes up. What about the oxygen in the soil? Goes up. How about your plant stand? When you're trying to plant those clods, pretty hard to get a good stand. Plant it in that mellow soil, get a perfect stand. You did one thing, improve the resilience of your farming system by just changing the application of calcium sulfur. Okay, take care of the soil life first. Kind of hit on that a little bit earlier. We're going to determine what biological community is symbiotic with your crop. Determine the environmental conditions that biocommunity needs. What kind of aeration does it need? How much water does it need? What are the right mineral balances for that particular crop? And gotta have the right temperature. You say, well, I don't control the weather. How can I control the temperature? Well, with, for example, cover crops, residue on the surface. It prevents that soil temperature from climbing so high. I've measured soil temperatures on a fairly nice summer day, maybe 75, 80 degrees. About perfect, yeah. Things are wonderful. That top inch of soil, 140. How much microbial life is alive and functioning at 140? Not much. But with some residue over the top of that, what's the temperature? About the same as air temperature. Pretty comfortable, pretty nice. Everything's working good. So you can control temperature to a certain extent. Soluble carbon. A lot of people don't even think about that. But we've heard quite a bit of discussion about how important carbon is, the carbon cycle, and how we get that energy into the plant. So take a hard look at tests to tell you what the soluble carbon is. Very, very important. Your carbon-nitrogen ratio, getting that properly balanced. I saw a field this year where corn stalks had blown with the terrific winds that we've been having, blew all the corn stalks into the road ditch. It took a loader and pushed the stalks back out of the ditch, kind of just spread them out in the field, just across the end rows. They'll digest and add some fertility back, so it seemed like a good plan. What do you think the corn crop looked like in those end rows? It was terrible. It was yellow. It was short. Well, why would that be? You have all those good nutrients there. What happened? Well, your carbon-nitrogen ratio was way out of whack. Because the bugs eat it first. They take the nitrogen first. In that plant, there's nothing left for the plant. So we know that cover crops will protect and feed that soil biocommunity. Jerry Hatfield was the director of the National Lab for Agriculture and Environment, and I've heard him say many times, you have to feed the critters there in the soil. How much is it? Well, it's about the same amount that it takes to feed 3 elephants. Well, if you've ever carried bales of hay to feed an elephant, which probably none of you have, trust me, they can eat a lot. You think a horse eats quite a few bales, think of what an elephant will do. You have to have that much food for all of the microbial life that you want. And the residue from our crops won't hardly do that. That's why we grow cover crops. We got to grow some food. What you're doing is just growing fertilizer. You're manufacturing fertilizer on your own farm. Remember what I said, not so reliant on sources of funding, outside sources of funding? Well, there's one little thing you can do, make your own fertilizer. I like to see quite a bit of diversity in the cover crops. I've gone to a lot of regenerative agriculture meetings, and boy, it's rah, rah, rah for the cover crops, and they're growing rye, and they're growing rye this tall, and they're rolling it down. They're not doing that in northern Minnesota. It doesn't work too well. Why? Well, it's not adapted for that kind of climate. What do you want to use in a more northern climate, like where we are right here today, or north of here? Well, you could use oats. You can kill oats pretty easy. You don't have to have a roller. Mother Nature will do that for you. Because it freezes and they die. So pick species that will give you, some nitrogen, some good root growth, like oats. Oats will bring silica into the soil really well. Oats are really good at detoxifying soils. You say, well, it's so late when I get done with the harvest and get that cover crop planted, my oats only got that tall. What good is that? Look in the ground. How deep of roots did that oat plant have? Well, the roots are about like that. I did my master's degree in studying oat roots, and I found they can grow a huge amount of roots. I washed out roots until I was sick and tired of washing out roots. But oats are really good. And what's feeding that microbial community? The exudates from those roots. So even though you only got about that much growth, you did a lot of good in that soil. One of my pet peeves is, wow, you need a green crop early in the spring. Well, when you're down south, yeah, you do. So like from here on south, maybe that's a pretty good plant. But from here on north, maybe not quite so good. What happens as you go further north? You have a very quick spring. I used to farm up in northwest Minnesota, and the first year, I'll never forget it. I went up there, loaded my machinery on the trailer, and hauled it up there. I could not get up the lane because of the snowbanks. And, boy, it'll be a month before I can farm up here. So I kind of went around, got out in the field, got around, unloaded my tractor and some tillage equipment, and headed back home, back to Algona. And I thought, well, I'll get that planting done. I'll have plenty of time to go up there and plant. And I hadn't started planting yet in Algona. Got a call from my neighbor up there. Hey, you gonna plant? I can help you if you need some help with planting. I said, well, I was just up there and I couldn't even get up the lane for the snowbanks. Well, we're all done planting around here. Well, I had a real good education there. That's fast country. It happens fast. And that was shocking. I got up there, got the corn planted, got everything done. Same thing happened. I came back and I thought, well, I'll get the corn cultivated here and get some spraying done. Neighbor calls me again. You got to get up here and kill those weeds because they're bigger than the corn. I went up there. Whoa, my corn in Algona was about like that. The corn there was about like that. The weeds were about like that. Fast country. It takes a different farming system to make that work. And so you don't have time to play with a cover crop in the spring. And when you take a cover crop like rye, how do you kill it in the spring? Well, I'll spray Roundup on it. That'll get rid of it. Let's see, that is an antibiotic. So I'm killing all of the good bugs that I just saved all winter. Make too good a sense. Pretty strong metal chelator. Tied up all my manganese and copper and zinc. Maybe not a good part of the system. Further south, you can let it grow a little taller. Hit it with a roller. Works really good. I've been doing some work on Maui, in Hawaii. Really beautiful weather. Grow that rye up pretty nice. Get a roller crimper on the front of your tractor and roll it down and have the planter behind you. Works great. Had nice warm weather. That whole thing decomposes. Get that green material laying there on the soil, and you got a lot of microbial life working. Just like that, that residue is gone. It's gone almost too fast. Doesn't work in a little bit colder climate. So a lot of things to do there. Be creative when you think about it. How do we test whether our soils are in good shape or not? I start with like soil quality tests. You heard Liz talking yesterday about respiration, soil respiration. Kind of is a good measure of how much life do you have in that soil. I do an infiltration test. You can do that. It's really simple. Just take a little piece of pipe, got maybe a 6-inch piece of pipe, maybe 5-inch pipe, PVC, whatever. Just cut yourself off a chunk. Kind of tap it into the ground. Calculate how much water it takes to put an inch of water in that. I put some cellophane or saran wrap or whatever in that pipe, pour the water in, get out my stopwatch, pull it out, time how long does it take that water to go away. If it goes away in 1, 2, 3 minutes, you got a pretty good water infiltration rate. Check it again, take the same place. Now you got that surface that was dry, kind of soaked up. Put in another inch of water. Time that. How long does it take? Well, it's gone in 2, 3 minutes, 5 minutes. Excellent infiltration rate. If it takes 3 hours, not so good. If it takes longer than that, which I find quite often, not good at all. Because that rain that you get that thunderstorm that dumps a ½ inch of rain in 10 minutes, 15 minutes, 20 minutes. How much rain did you get? Wasn't all of it. It ran off, disappeared. Very important test you can do. The bulk density tests, they're important. Electroconductivity is important. It's an interesting measure. I used to do a lot of electroconductivity testing, driving back and forth across the field, making maps, and then I noticed that my electroconductivity map looks just like my yield map. You lay them over each other. Okay, so why go to all the work of doing all this electroconductivity testing when I can look at a yield map, get the same information? So those yield maps that you're making are very useful, not only for bragging at the local coffee shop, but you can use them to make decisions on the nutrient balance in your soil. Aggregate stability test, really important. Are you producing enough glomalin to hold the soil particles together? And the way this test is really simple. Get something that you can, like I cut off a little piece of PVC pipe, glue a screen on the bottom of it, put just some chunks of soil in it, and dip it in water. How long does it take for it to dissolve and go away? If it takes quite a while, you're in good shape. If the first dip, and you got nothing left, you don't have any aggregating materials that hold your soil together. So your soil will puddle, it will crust. We've all seen crusted soils. 1/32 of an inch. That's really small amount. Will seal the soil off and not allow CO2 to escape from the soil or oxygen to go back into the soil. And it will smother everything in the soil that needs oxygen. And then microbial life will just shrink very quickly. Earthworm test. Pretty simple test. Take a spade, go out and dig it up. You have worms? Good. Don't have any? Look a little harder. There's no wormholes in the soil. You just don't have any. And you have a real problem. They're a good measure of how healthy your soil is. So earthworm test, very important. Penetrometer. That's that little device that has the handles on it. You press down in the soil and measure how many pounds of pressure does it take to penetrate. If it goes over 300, your roots can't even penetrate in that. I've been on many farms, more than I'd like to see, that I push it down to 300, further. Pretty soon, I'm off the ground. And I've got it in about an inch and a half. That's not going to grow a crop. That's not going to allow water to infiltrate. It's not going to let CO2 escape. It's not going to let oxygen back in. So just something as simple as a penetrometer. You say, well, I don't have that. Just take a rod, maybe like a 3/8 inch rod, weld a handle across the top, push it in. If you can't push it in, you got a problem. Fix the problem. Okay, and other things it can do. Chemical analysis of the soil. Now I've listed here the typical things that you should test for. I don't see very many people doing that. They check for organic matter, pH, P and K. That's it. We're in pretty good shape and knowledge about those things. You need to go a little bit further. Look at the micronutrients. A lot of people look at like sulfur as a micronutrient. No, it's not. It's a secondary element, and the soil uses a lot of that. The crop uses a lot of sulfur. It's very good for sulfur-induced disease resistance. Builds protein in your crops. Very, very important. You need to know all of these things. And I get the comment quite often, I'll just put on, I'll use nutrient removal. I look in the book and if I had a 200 bushel corn crop, I removed this much. I said, what you're really doing is treating that soil like it was your checkbook, your checking account. So you put X amount of money into the checking account. Then you write checks. And then you call up your banker, because you're not very good at keeping records. You call up your banker and say, how much money do I have left in my checking account? And so you look at that, you put on nutrients on your soil, you grow a 200 bushel corn crop, you come out and do a soil test in October, see how much nutrients left. And then I'll put some more back on. If you want to use that money analogy, that's the wrong one. Look at it this way. Put the money in a trust fund. Now you know you never get that money back. What do you get? Well, I get the interest off the trust. Okay? So when you're soil testing, you're testing what interest rate is it paying. So you call up your banker and say, well, what interest rate are you paying on my trust? Well, it's 1.5%. That's not enough. Okay, how do I fix that? Well, he says, well, you can put more money into the trust, put more fertilizer on. Or, what else could you do? Find a different banker that's paying more interest. Okay. So you can do the same thing with the soil. Put these microbes to work. So they're providing more nutrients. And when do I want to test that? I like to soil sample it in the May-June time frame. Why do I soil sample in May and June? That's when the plant is taking up about 75% of its nutrients in that time frame. I want to know the soil's ability to feed that plant at that time. And so I do the majority of my soil testing then. Okay, how do you measure how well you're doing with your farming system? Well, I have a yield monitor, and I know that I saw I hit 314 bushel the acre. So you go to the coffee shop, tell your friends, yeah, I had 300 bushel corn this year. Okay. Did that tell, how'd you do that? Well, you don't tell them that. Well, I just saw it one time on the yield monitor. You say, well, I put on quite a bit of nitrogen this year, and you got something that you did. You tell them. But you're not learning anything. If you want to learn whether you're successful with your farming systems and changes that you've made, measure the yield components. Start looking at how many kernel row number do we have on that ear of corn? How many pods do we have on our soybean plant? What was the test weight? How many kernels per row did I have? How many beans per pod did I have? Look at yield components. Nothing you look at is crop Brix level. We heard a little bit about that yesterday. That's to measure the amount of sugar, for example, in the plant. A real healthy plant will have a high Brix level. One of the things that I grow aronia berries. I don't know if you know what they are, but they're a very astringent tasting plant. You put one in your mouth and you spit it out. And sometimes they call it a chokeberry, because that's kind of what you do. And I thought, why is that? Well, they have real high tannin levels, and tannins tend to be pretty bitter tasting. Well, can I do anything about that? I learned if I change the nutrition balance in that, I can make them good enough that if you put a bowl of them out, kids come along and, they'll tell you in a hurry. They'll spit it out if they don't like it. They'll eat too many if you aren't careful. They really, really taste good. What is the difference? Well, the sugar level is higher. So in those bitter tasting ones, I had a Brix level that was running around 7, 8. Most people are, well, that's not too bad. The ones that taste good, Brix level is running around 22, 23. Really good. You can do that with your corn, your soybeans, your oats, your wheat, your barley. Check the Brix levels. If it's high, you're doing things right. You can check plant pH. Very important. Plant sap analysis. Let's look at that a little bit. Mid-season checkup. Looking for the hidden hunger. The crop looks good, but is it? So what I do is go out and I compare the bottom leaf minerals to a fully developed leaf. So take some leaves off the bottom of your soybean plant, and a fully developed leaf stay off the top. Do the same thing with the corn plant. And evaluate that. Now you have to know what minerals are mobile in the plant and which do not move. So the most mobile to the least, nitrogen. That moves really quickly and easily. And phosphorus, potassium, magnesium. Work your way down to get to manganese. Manganese doesn't move at all. So what does that all mean? Well, check the plant. If you have the lower leaf has hardly any nitrogen, and the top leaf has adequate nitrogen, what's that tell you? The soil ran out of its ability to supply nitrogen to that plant. So it cannibalized the lower leaf, moved it to the top. Now let's look at manganese. You sample the lower leaf, manganese level is great. Okay, we're good. Look at the top leaf. Manganese level is really low. So what happened? Soil didn't have the ability to provide enough manganese to feed the plant clear through to maturity. So you've got to fix that problem. And that's a good time to do it. You can do that with foliar feeding. Does a pretty good job. So that's where I find sap analysis or leaf tissue analysis on these upper versus lower leaves to be very, very useful, very helpful.
Mike, where are you having your sap analysis done?
Well, you can, there's some places, new labs in Oregon that have just come up. When we first started doing it, we had to send it clear to the Netherlands, and that was a real pain, but it was certainly worth it. But you tended to do that more with high dollar crops, like strawberry production, vegetable production. But you can do it with the corn, soybeans. But now that we have more labs springing up in the U.S., it's a lot easier to do. But I guess I like to be frugal. We'll say that politically correct, frugal. I'll take a lower leaf and an upper leaf and just do a typical tissue analysis at Midwest Labs, for example. Well, that works pretty good. It gives you a rough idea of what's going on. Maybe not as precise, but it's a quick and dirty answer that will make you quite a bit of money. Definitely worth doing. Using crop inputs that end in side means that you're treating the symptom, not the problem. So we're going to talk a little bit more about that. You're using a herbicide. Well, why are you using a herbicide? Well, I have weeds. I'm using fungicide. Well, why are you using a fungicide? Well, I got fungal diseases. But you're treating the symptom, not the problem. So let's look into treating the problem. Each plant species, we talked about that, has a specific set of nutrient ratios under which its symbiotes thrive. Notice that a field not planted to a crop will develop patches of weeds of varying species in different parts of the field. So you got a bare field, you've tilled it so it's just totally black. Just let it go. And what happens? Oh, I got a patch of thistles over here. Got a patch of giant rag over here. Got a patch of lamb's quarter over here. Why is that? Oh, most of my life I said, well, that's because the ragweed went to seed there and spread the seed, and we got a patch of ragweeds going on. What I learned is that weeds, insect infestation, and plant diseases are all indicators of soil nutrition. Really? Well, that's kind of handy to know. I don't have to do a soil test. I can just go out and look and see what weeds growing there. I know what that area of the field is deficient in. Because a plant is a product of the conditions in which it grows. Therefore, it's a measure of those conditions. They're an excellent indicator of soil health. So any imbalanced mineral ratios are going to grow different plants. Well, giant ragweed, I remember my grandfather used to say, he called it ironweed. Why did he call it ironweed? I thought it was because it was tough as iron. When you try to cut one of those big ones down, you have to have an axe to chop it off. So I thought, well, it's ironweed. No, he knew that that area was short of iron. You supplement iron, they go away. When the soil has an adequate iron ratio, and that you can't just run a chemical test because it doesn't separate the ferric and ferrous iron. You need reduced iron. If you don't have, you could have real high iron levels and have all kinds of giant ragweed. You say, well, he doesn't know what he's talking about. Well, if you have reduced form of iron, the ragweed goes away. Other things that can affect it: improper soil aeration, improper drainage, compaction. Compaction's a nasty thing. We've gotten bigger and bigger machinery. We've tilled the land, we put on a lot of anhydrous, potassium chloride on our soils. Real easy to pack them down. And it causes lots of problems. Now, having said that, I gave you a specific example, but rarely is one weed species a result of one soil condition. You kind of look at groups. For example, if you have a lot of grassy weeds, you have a calcium problem. You do not have adequate available calcium. I've seen fields of woolly cupgrass so bad that I couldn't tell what crop was planted there. Just nasty. Applied gypsum, because his pH was already high. Says, I don't need calcium, my pH is 7.3, 7.4. Applied gypsum, gave us available calcium. The woolly cup just kind of disappeared. Got down to a level that he could at least maintain it. It didn't just overwhelm the field. Same way we look at broadleaves. Look at water hemp, pigweed. What's wrong there? Well, we have an imbalance in our phosphorus-potassium ratio. And so we got to fix that. I just picked a few things. If you have typical weeds that are found on minimal soil health, chickweed, chicory, groundsel, these kind of things, lamb's quarter, you have some health issues of soil starting to occur. If you have bad soil health, you'll see daisy, wild carrot, wild radish, wild parsnip, chicory. I wanted to show some of those. Common mullein. Now, if you have serious soil health conditions, you have velvet leaf, Jimson weed. They're indicators of really some serious things. So, abundance of broadleaf weeds, you have a phosphorus-potassium ratio greater than 1 to 8. Now look at your soil test and see where they are. As this ratio broadens, herbicides won't even work. Your black slate, nightshade. So what weeds tell you? You know, grassy weeds, you have improper calcium-mag ratio. Ratio 5 to 1 is appropriate for most soils. High mag makes soil particles stick together, causing lack of oxygen in the soil. You have more Johnson gas. Excess aluminum, telegraph plant. Shortage of copper and zinc. You get a weed that I don't see very much of around here, but Florida pulse-leaf will occur. Now, same thing occurs with diseases. If you have an imbalance of micronutrients, you're not going to get the proper phytoalexins produced, antioxidants or flavonoids produced. You're not getting proper mechanical barriers. Your chemic pathway shuts down with the manganese that's short. So no cork production. The fungal tissue can penetrate the leaf and just spread like crazy. If you have adequate manganese, then that'll shut that down. It also helps build stronger cell walls. Creating proper balance of potassium in soil reduces bacterial and fungal diseases. Potassium deficiency causes cell walls to become leaky. When they leak, insects can move in on them. Ammonium-based fertilizers increase fusarium and phytophthora diseases. Nitrate-based fertilizers have the opposite effect. Anything that prevents a plant from obtaining necessary nutrients for growth, reproduction will invite disease. So soil compaction, reduced water holding capacity, all of these things, excess tillage. There's our 1/32 of an inch, holding that CO2 in the soil. Tillage, trafficking on soils, will cause compaction and crusting. Both increase disease. And when you use disease, you plant more fungicides. Not good. Same thing with insects. You get the right micronutrient balance, you don't have insect problems. Kind of watch what the plants are telling you, because they always tell the truth. So, principles for achieving resilient farming. Avoid biased advisors. Carefully observe successful systems. Ask a lot of questions. Make decisions. That's the hardest one. Because what I hear the most, well, yeah, I think I'll try that. No, steady it. We never make bad decisions purposely. We make bad decisions because we lack information. So if you study it out, make a decision, and then make it work, you'll be successful. All right. Thank you.